Okay, gang, we're going to finish the practice test, number 2. So we're ready for problem 7E, which is a graph. We're going to graph this thing. So the first thing that I would suggest that you do is sketch in your curve. So we're going to sketch in our cosine curve. Guys, you've got to know your basic shapes. So we're going to sketch in that cosine curve. We're going to recognize from the equation that the amplitude, or the height, is 5. And we know these labels are supposed to be this, but they're not anymore because we put this number in there. And what does that number do? That number divides these. It divides the period. It divides the horizontal. So 90 divided by 4, 180 divided by 4, 270, and 360. So our amplitude is 5, and our period is 90 degrees. Now we're on to problem 8. We're going to type in 287.175, and then we're going to go to second angle and down to DMS, because DMS stands for degrees, minutes, seconds, which is what we're supposed to be doing. So we should get 287 degrees, 10 minutes, and 30 seconds. So second angle, DMS. That's all there is to it. Now, since I'm in degrees right now, for problem 9, I'm going to go ahead and do all of the degree problems first. So I'm going to do B and D and F. I'm going to do those first because they are degree problems. They have a degree sign, and my calculator's in degrees right now. So here I go. Cosecant, this is B. Cosecant, 1 divided by sine, 183 second angle degrees, 21 second angle minutes, and 3 alpha plus. That's the tricky one. And I got negative 17.1087. 10,000th, remember, means 4 decimal places. So negative 17.1087. Now D, same thing, only it's just tangent. 321 second apse, or second angle degrees, 58 second angle minutes. And that is D, negative 0.7822. E, no, not E, F. F, secant, 1 divided by cosine, 23. 1.0864, 1.0864. Remember, to get a secant on your calculator, you have to do 1 divided by cosine. Just like to get a cosecant, we did 1 divided by sine. Now, change your calculator, go to mode, change your calculator into radians. Now we're going to type in the other ones, typing them in the same way, but now we're in radian mode. So second tangent, I'm doing A, 1.375, 0.9420. Cosine, 1.75. Don't make these hard, guys. Just type. Just type. Negative 0.1782. And then sine, 18 pi, and please use your pi button. Don't do anything else. It's sine 18 pi divided by 77.6701. Now, please heed this little hint. The only problems on the test just like the only problems on the practice tests that use radians are the ones right here in this section. So as soon as you're done with that section, change your calculator back into degrees, because every other problem you do on the whole test is going to be in degrees. So set your calculator in degrees. Okay? Now, number 10. We're finding x. And x is an angle. Okay, so we know that means we're going to do something a little special. But first, we're going to write our equation. And the equation for this picture is a tangent. So tan x equals 8/9 opposite over adjacent. When the x is an angle, then we have to do second. In this case, second tangent. We only do that when we're looking for an angle. So here we go. Second tangent, 8 divided by 9, and that's 41.63. When you write your equation, the angle is always hooked right to the tangent. The only way to get it unhooked is to do second. 41.63. Now the next one, the triangle is not situated the same way, but you're going to do it exactly the same way, even though the triangle is like on its side or whatever. So this is 63 degrees, this is 12, this is x. You must pay attention to where x is. X is the hypotenuse. This is the opposite. For this angle, this is the opposite side and this is the hypotenuse. So we're going to say sine 63 equals opposite over hypotenuse. See, that equation is different than this one. I don't need to unhook this. I need that to stay together. So x sine 63 equals 12, and x equals 12 over sine 63. I got 13.47. There's so much to remember, guys, and one of the things you have to remember is that when you're drawing a course, you're using a compass. I got the compass wrong right there. You need to remember where the labels are. So 310 would actually look like this. This is 310 degrees. It's past 270, but before you get all the way around. 310 degrees. Now on your test, remember it looks just like this. Your test looks just like this. So you're going to have a problem like this, where you have to find the exact answer and the calculator answer. And the calculator answer is the decimal. I'm just going to type it in. Cosine, second sine, 1 divided by 3. Notice I didn't do anything fancy, I didn't do anything tricky, I just pressed the buttons that are written right here. 0.9428. Now, doing it by hand, a little more involved to do it by hand. So first of all, that's a positive number, so I'm going to draw it in quadrant 1. Remember, with these kind of problems, you always start with the parentheses. So I'm looking for an angle whose sine is 1/3. Sine is opposite over hypotenuse, so 1/3 would look like that. Okay? Now, what's the adjacent side? Well, I don't know, but I can do the Pythagorean Theorem to find it. So x squared plus 1 squared equals 3 squared. Remember, it's always leg squared equals hypotenuse squared. So x squared plus 1 equals 9, x squared equals 8. X equals the square root of 8, which is 2 square root 2. So far, all I've done is draw a picture of this, right here. Now, I'm going to find the cosine of it. So look at that picture. What's the cosine? The cosine is here's your angle. The cosine is adjacent over hypotenuse, so that will be 2 square root 2 over 3. This is the exact answer. So when you do this problem, exact means do it by hand, which means draw a picture, probably do the Pythagorean Theorem. On the calculator, the decimal, we just type it in. All right, all we have left now are the word problems, and remember, I got 5 of them here, but the test won't have 5. It's probably have more like 3, I don't know. I just wanted a lot of practice here. So here we go, number 1, we got a squirrel on the top of a tree, imagine that. And he's looking at a nut on the ground. And the nut is 52 feet away from him. So in other words, the nut is 52 feet away from the squirrel. So this is 52. There's the squirrel, there's the nut. They're 52 feet apart. The angle of depression is 17.7 degrees, and we want the height of the tree. So make sure your picture looks like that. And then write an equation. Well, let's see. We have opposite and hypotenuse. So sine 17.7 equals x over 52. I can't emphasize enough, guys, when you write your equations, the angle is hooked to the sine. Don't put sine 52 or something crazy. The angle is hooked to the sine. And then it equals, in this case, opposite over hypotenuse. So this is an easy one. We'll just multiply by 52. Go to the calculator. 52 sine 17.7. And I got 15.81. So I'm going to put a unit on that because I always put units on my word problems. But 15.81 feet tall is the tree. All right. Now we've got a fish in the water. Okay, so here's the fish in the water. He is 100 feet from shore, so here's the jetty, which is just like a, what do I want to call it? It's just kind of like a little ridge they build to hold in the water, to calm the water down so boats can get in and out. So it's like a wall. It's like a wall. So we've got a seagull is up here, and he's 12 feet above the ground. The fish is out here 100 feet from the shore, and we want to know the angle of elevation. I hope you're thinking tangent, opposite and adjacent, so tan x equals opposite over adjacent. Now this is one of those where we have to break this apart. We have to figure out what x is, and the only way to pull it apart from the tangent is to inverse tangent it. That's how you find an angle. Second tangent, 12 over 100. So second tangent, 12 over 100 6.84. So that angle is 6.84 degrees. The unit's degrees because it's an angle. We got a plane approaching an airport. Find the desired angle. Don't forget the fancy words I use. Where do we always put our angles? Find the desired angle of descent if the pilot wants to land at a point that is currently 7,000 feet from the plane. The point at the airport is 7,000 feet from the plane. So this is 7,000. And the plane is 235 feet above the ground. I hope you're looking at that situation and thinking sine. Sine x equals opposite over hypotenuse. This is just like that. Somehow you got to pull that x off, and the only way to get that x off is the second sine, inverse sine. That's how we find angles. We inverse sine, or tangent, or whatever. So second sine, 235 divided by 7,000, 1.92. So this angle is 1.92 degrees. Now we have a flagpole. And the flagpole is making a shadow 16.62 feet long. Shadows are on the ground. And the angle of elevation is 64 degrees. And I want the height of the flagpole. So look at your picture. Make sure you got it set up like this. If you have an issue with that, either lean over and ask your neighbor. Go to the Learning Commons or come in to see me for office hours. Got to be able to draw this picture. So here we go. Tan 64 equals opposite over adjacent. So x equals 16.62 tan 64. Multiply this over to here. So 16.62 tangent 64. I got 34.08. 34.08 feet is the height of that flagpole. All right, one more. We got a man looking at the top of a building that's 48 feet tall. He is standing 3,000 feet from the top of the building. So that's 3,000. The man is standing 3,000 feet from the top of the building. And we want to know the angle. I hope you're thinking sine. Sine of the angle equals opposite over hypotenuse. The only way to find an angle is the second sine. Second sine, 48 divided by 3,000, 0.92, that's a tiny little angle, 0.92 degrees. I typed that in right? Yeah, I think I did. Yep, 0.92 degrees is the measure of that angle. And there's your second practice test, guys. Good luck.